So excited for school today. Can't wait to bring this into show and tell.
Brendan, how many times do I have to tell you to do your laundry before school?
Ow, Mom. Alright, jeez, I'll do it. But can Jason help me?
Only if you can get it into my basket.
So our problem is, Brandon has a pair of dirty socks that he rolled up into a ball. He has school in 2 hours, so he must get the socks cleaned before then. Jason has agreed to help Brandon do his laundry under one condition. Brandon has to throw the socks into the laundry basket at the same height as the release point of the socks. Help Brandon make some motion graphs of the data for his throw.
1, 2, 3. Okay. While the socks are traveling on their parabolic path, they will experience an acceleration of negative 9.8 meters per second squared until reaching their max height. And on the way down, they will have an acceleration of 9.8 meters per second squared. The graph of the socks' y direction motion will represent a parabola, and the x direction graph will represent a positive sloping line.
Alright, so this is a representation of me, Brandon, and this is a representation of Jason. And this is going to be the path of the sock, and this is going to be the socks at the max height. So going up, acceleration is going to be negative 9.8 meters per second squared, and going down, acceleration is going to be 9.8 meters per second squared. And this is going to be the final the laundry basket where it lands. Alright, so this is our position versus time graph. We found each of these points by just taking the time from the video and going frame by frame and finding the height at that point. So as we hypothesized, the y displacement makes a solid parabolic shape. Alright, so this is a velocity versus time graph, and so we just found that by taking the derivative of this. The velocity keeps continuously going down since gravity. So since if our velocity going up is positive and gravity is acting down on it, that's gonna make our velocity smaller until it's negative. And this is our acceleration graph. From this, we just took 3 points. It doesn't really matter since acceleration for our whole thing is negative 9.745 meters per second, which is really close to the acceleration of gravity. And from that, we just get a straight line. So these are our data points, and for our video analysis on Logger Pro, it gives us the x, the y, the x velocity, and the y velocity. The only thing is, it started at 1.277 seconds, but we have to, so that's our beginning, so we change that to 0, and we also changed this point to, we subtracted the 1.277 since that's the set point. And from here, we made a table of it. So at 0 seconds, our velocity is 0, there's no acceleration, our speed is 0, and it's at rest. From the interval before the max height, our velocity is positive, our acceleration is negative since gravity's acting against it, and our speed is slowing down, and our position, it's moving up. And at the midpoint, and at the halfway point where it's at its max height, the velocity is 0, the acceleration is unknown, speed is 0, and it's at rest. And the interval after that, our velocity is now negative since it's going in the opposite direction. Acceleration is still negative, and it's now speeding up. And it's also moving down. And at the final point, when it's in the basket, we get 0.766. Our velocity is 0, our acceleration is unknown, our speed is 0, and it's at rest. From this, our equation, this was our equation, negative 4.085 time squared plus 13.94 time minus 10.06. And for our velocity equation, it's not a direct derivative of it since we use logger pro for it. So there's a little bit of error here, but we got our velocity equals negative 9.475 time plus 16.52. And a direct derivative of that gives us our acceleration, which is constant and consistent.
I just threw it into the basket, so now you have to help me do my laundry.
Alright, let's go.
Alright, Jason, let's do this laundry so I'm not late for school. Yes. Alright, that's done. Alright, put it in the dryer now. Okay, that's done.
Put your socks on, Brandon.
Oh, sweet, thanks. My mom's gonna be so happy.
What's going on in here, boys?
I just finished my laundry.
Go, it's going.
He's coming, you can't do that.
But